Discussion of the coordinate plane the other day, we are now going to be focusing on some transformations in the coordinate plane. And transformation is nothing more than a movement of a geometrical image. There are 4 different types of transformations. Let's go ahead and write down all the different kinds. They are reflections, translations, dilations, and rotations. These are actually probably some words that you might use in your everyday life, so you probably have a good understanding of what they mean mathematically already, but we'll go ahead and take a look at an example of each. It's important to note a key word here, vocabulary, is the preimage. A preimage is the position of the figure before it undergoes a transformation. So let's take a look at a few preimages here first. Here's a preimage of a triangle that we're going to reflect, and a pretty sweet parallelogram down here that we're going to do a dilation on. We've also got a trapezoid up here, as well as another triangle over here that we'll be doing a translation and a rotation. Let's start with our reflection here. When performing any type of transformation, always focus on the vertices of the geometrical figure and think about what's going to happen to the x and y coordinate here of the vertices. There's a rule for each transformation of what's going to happen to the x and y coordinates of the vertices. And in a reflection, there's 2 different types of reflection. There is x-axis reflection, and there is y-axis reflection. So let's go ahead and take a look at y-axis reflection first. Thinking about reflecting each of these points over the y-axis. What happens in y-axis reflection is that every xy coordinate point turns into a negative x, y. So the x coordinate of each of these points just becomes negative. So instead of 3, 5, we now have negative 3, 5. And instead of 1, 2, the reflection of that point across the y-axis is a negative 1, 2. And the reflection of 4, 3 is a negative 4, 3. And there you can see reflection across the y-axis is just acting as if the y-axis was a mirror, and we mirrored this image over it. So if we want to mirror the image over the x-axis, we want to take every ordered pair and make the y value become the opposite. So I'm going to think of every xy ordered pair to become x negative y. So 1, 2 becomes 1, negative 2. And 4, 3 becomes 4, negative 3. While 3, 5 reflects across the y-axis to become the ordered pair 3, negative 5. And there you have a pretty sweet reflection across the x-axis. Some of you might start to think of a translation as a slide transformation. Sometimes it's referred to as that. In this particular translation, well, in every translation, you simply add a value, a constant value, to all of the x coordinate points and add another constant value to all of the y coordinate points. So every xy might get a 7 added to all of the x coordinates, and in this case we're going to subtract 1 from all the y coordinates. So to translate this pretty sweet trapezoid here, I'm going to take negative 5, 4, I'm going to add 7 to the x value, which brings it all the way up to 2, but take 1 away from its y value, which takes it down to 3. So here I am at 2, 3. And I'll do the same thing with negative 4, 3, which brings us all the way up to 3, 2. And I'll go ahead and do that to all the points as well. Negative 1, 4 brings us all the way up to 6, 3. And when I slide negative 4, 7, it brings us over to 3, 6. And there's your translation. So now let's go ahead and take a look at the third one that we discussed earlier, which was our dilation. In a dilation, this is the only one where the size of the image is going to change. And in a dilation, every ordered pair gets multiplied by a constant value, as opposed to if you remember on the translation, we added or subtracted a value to all of the ordered pairs. Here we're going to multiply both of them by a constant value that we call a scale factor. So here we're looking at a scale factor of 2. Every x coordinate will be multiplied by 2, and every y coordinate will be multiplied by 2. So each of these points, let's start at 3, 2, and have it undergo a dilation with a scale factor of 2. It will go to 6, 4. While negative 1, 2 will go to negative 2, 4. Negative 3, negative 1, under the dilation of a scale factor of 2, will become negative 6, negative 2. And 1, negative 1 will move to 2, negative 2. And here's your parallelogram under a pretty awesome dilation of scale factor of 2. Finally, we're going to get Tony Hawk here to help us out with some sweet rotations, starting with a rotation of 90 degrees. We'll go 90 degrees counterclockwise. And whenever we rotate, we think about rotating around the origin. So if I were to put my pen right here at the origin and rotate it 90 degrees, that's what the image should look like. But how do we actually do that without turning the paper? We simply take every xy coordinate and we flip x with y. The y value becomes the x value and the x value becomes the y value. But we also make the y value become opposite. So 2, 5 would become a negative 5, 2. While 2, 2 would become a negative 2, 2. And finally, 4, 2 would become a negative 2, 4. And there's your 90-degree rotation around the origin. But there's one more type of rotation that we'll talk about here, and that is if we want to rotate 180 degrees. When we rotate 180 degrees, it's a little bit easier to think about. Every x and y coordinate will just change to its opposite. So let's start by rotating 2, 2, 180 degrees around the origin to negative 2, negative 2. While 2, 5 rotates to negative 2, negative 5. And 4, 2 will rotate 180 degrees to negative 4, negative 2. Correction, this one here is negative 2, negative 5. And this one is negative 4, negative 2. And here is your 180 degree rotation around the origin.